Hello everyone. I, Dr. Meenal Nerkar, welcome you to this session on Sentinel Search algorithm. In today's video, we will learn what Sentinel Search is, how it improves linear search, its algorithm, implementation, and complexity analysis. So, the idea behind linear search is to compare the element to be searched with the element in the list one by one using a loop and stop as soon as we get the first instance of the element to be searched in the list. So, uh, in the last video, we have seen how it works. Okay, so in linear search, every iteration performs two comparisons. Okay, every iteration performs two comparisons. One for checking is the current index within the array, and the other for checking is the current element same as that of the element to be searched. So now, considering the worst case in which the search element does not exist in the list of size n, then the simple linear search will take a total of 2n plus 1 number of comparisons, out of which n comparisons are against every element in the search list and n plus 1 number of comparisons to test against the end of the loop condition. Okay. So the total number of comparisons that are required in total in linear search are n plus n plus 1, that is 2n plus 1. Okay. In the Sentinel linear search, the idea is to reduce the number of comparisons required to find an element in the list. Sentinel search is optimized version of linear search in which last element of the array uh, in which the last element of the array is temporarily replaced by the element to be searched. We are calling it as a sentinel. So the last element is the sentinel one, which gives us the guarantee that the search key will always be encountered somewhere in the array. Therefore, we only need to compare array elements with the key without checking the loop boundaries every time. Once the replacement is done, we are running a loop to see if there exists any instance for the any instance of the search element in the list, and quit the loop as soon as we found the search element. Sentinel search, so in the Sentinel search, the total number of comparisons that are required are now reduced to n plus 1. How? Because if you see this looping construct, which is running over the given array, and the size of the array is n plus 1. Why n plus 1? Because n is the actual size of the array, and at the end we have added the element to be searched. So the size becomes n plus 1. As the size becomes n plus 1, the total number of comparisons that are getting done in this loop are n plus 1. And one comparison is done over here, okay, to check whether we reach to the end of the array or not. So in total, n plus 1 plus this 1, that is n plus 2 number of comparisons are done. So if you see this example, if the array is containing the elements 12, 25, 17, 40, 31, and 55, and the element to be searched is 31. So what we are doing is this 31 we are appending to the array. Okay, so we are appending it to the array. And now, sorry, there is one mistake over here. So here in between 31 and 50, this 31, there is a 55. Okay, so we are appending the element to be searched 31 at the end. So now whenever it is searching the element, instance of the element 31 in the array, it will start from the index 0, then 1, 2, 3, and 4th. So at this index we found the element. So the total number of comparisons required are 1, 2, 3, 4, and only 5 number of comparisons are done over here. Now the best case, worst case, as well as average case time complexity of the Sentinel search is same as that of the linear search. However, it performs fewer comparisons per iteration, making it slightly faster in practice. Now, coming to the comparison between the linear search and the Sentinel search, if we see, the boundary check is done in every iteration in case of linear search, whereas that is removed in the Sentinel search. Then the number of comparisons required in linear search are more, and the comparisons are fewer as compared to the linear search in case of Sentinel search. Now, coming to the time and space complexity, it uh, time and space complexity of the Sentinel search remains same as that of the linear search. Okay, then the implementation of the linear search is simple, whereas the implementation of Sentinel search is slightly more complex. Now the performance of the linear search is good, whereas the performance of Sentinel search is slightly better as the number of comparisons are reduced. So to summarize, Sentinel search improves the efficiency of the linear search by eliminating repeated boundary checks, resulting in fewer comparisons while preserving the same asymptotic complexity. It is a useful optimization for sequential searching in unsorted array. Thank you for watching.